this video, we're going to talk about conditionals. This is sometimes referred to as branching or logic branching in your code, or if-else statements. And you'll see where that terminology comes from as we move through this. We'll start off with a short lecture with a few slides where I'm going to talk about the concepts behind conditionals, give you a few pictures in your head to try to keep remembering what all these things mean, and then we'll get into some code. Okay, so let's look at conditionals in Python. I note that conditionals are found in most all programming languages, not all, but most. Okay, so what is a conditional? The way you want to think about this is that you are allowing your computer to make a choice. It's come to some point in the program, maybe it's some data input, maybe it's something else that it's calculating, and it has to make a choice about what to do next. Does it stop the execution? Does it change what it's calculating? When you come to a fork in the road, take it. Is this motto attributed to Yogi Berra, the Yankee catcher? I'm not sure if it was really him, but this idea that you've got to make some decision. Do I go this way or do I go that way? And sometimes, if I'm going to use this picture of these train tracks, this can be very complicated. You might have a code that has 20 or 30 different choices to make, sometimes even much more, and it's up to you to keep track of everything to make sure it's doing the right thing. You want to think about this maybe as an if this, then that, if you've ever heard that terminology. If this happens, then do something. If something different happens, do something else. And if none of those things happen, well, you still have to have some default option of what to do. And if you've ever read any of the Choose Your Own Adventure books, I mean, I'm quite old, but when I was a kid, they had these mostly for, I would read them sometimes for Dungeons and Dragons type stuff, sword and sorcery. Choose Your Own Adventure is you're reading in the book, and the character has to make a decision. And if the character decides to do one thing, you go to page 22. If the character decides to do something else, you do page 33. And then from that point, you might have another choice to make after a few pages and so on. And in this way, you can create your own story with the same characters and stuff. And so your program maybe may wind up at different places in its output, depending on what the input is. This is also sometimes referred to as a decision tree or control flow. The program that you're working on may branch off depending on what decision is made at different times. You can think about this as a big tree, or you're controlling how the program goes. And I was looking at one point for decision trees online, and I found this, it actually works pretty well. How does a cat decide whether to scratch on something? But it starts off right here for the decision. Am I supposed to scratch on it? If it says yes, and then of course the cat is going to scratch on it. If it is supposed to scratch on it, no, then it thinks about, well, how much is it worth? If it's not much, how many times have my owners yelled at me not to scratch on that? Countless times, definitely scratch on it. Barely, not ever at all. Will my owners be really pissed if I scratch this up? If they say no, don't scratch. But if they say yes, definitely scratch on it. And there's a whole bunch of these little funny memes and stuff out there. But that's the idea of conditionals. You keep asking yourself if you should do something, or the program should do something, and then depending on the answer, you do it. The syntax looks like this. For the simplest conditional, it's an if-else statement. So suppose you have some variable equal to 10, and your program says if x is greater than, and we'll go through all the different options for this when we go into the code. If it's greater than 5, print greater than 5. And let me point out a few things here. This if part of the if statement is ended by a colon, just like our functions and our loops. And then everything that is done if this occurs is indented. And I could have 5, 6, 7, 20 different lines, and if they were all indented, they would only happen if this condition is met. If it fails this, if x is not greater than 5, then or else print less than 5. So if this is true, it does this, and it never gets here. But if this is false, it says if x is greater than 5, nope, that's not true. I'll go to the next option. I next branch in my conditions. else print less than 5. And we'll find out that there's another way to have even more options, and this elif is a smushed together else if. So if x is greater than 5, print greater than 5, or else if x is greater than 1, print greater than 1. Otherwise, if nothing else happens or else, print less than 1. Okay, so let's get started. So again, we're going to go through conditionals and branching, control flow. This refers to having the computer do something based on the conditions, and usually these are the values of variables at some point in your program. Again, maybe they could be input from something, maybe they could be something that it's calculating, and at some point you want the program to do something else. And we'll do this with if-else statements. You can think about this again as branching, the way your code starts off at one point and then branches off or splits into 2 or more paths. You can think of this as a tree branch splitting off. For comparing numbers or even strings, we have these operators. That's what they're called right here. You have the greater than symbol, the less than. If you want to do greater than or equal to, you do greater and then the little equal sign, and there should be no space between them. If it's less than or equal to, you have the less than sign and the equal sign. And if you want to test to see if two things are equal, you actually need 2 equal signs next to each other. If there was just 1 equal sign, then it would just set the variable equal to itself. So 2 equals means that they're testing each other. That's why you have 2. Now this returns a data type. It's not an integer, it's not a float, it's not a string. It's called a Boolean. And this Boolean takes on one of 2 values, true or false. And you'll find that you can actually turn these into integers where true is 1 and false is 0. Now, true and false actually have a meaning in Python. So if you use this capitalization and you spell out true, that means something to Python. You should never name your variables true or false. You can also test to see if 2 variables are not equal to each other. So you have a little exclamation point and then the equal sign. This is true if they are not equal to each other. So the little exclamation point is like the not equal to each other. Okay, so let's try some of these out. I've set some variables here, a equals 10, b equals 20. And then I've got these words here, which are just strings. And we're going to test to see if they are the same or not. So let's see what happens if I print b greater than a. So b is 20, a is a, and if I run this, it takes a moment, the first time I execute it, I get true down here because that's true. And if I were to print b less than a, I would get false because b is not less than a, b is actually greater than a. So you can see it's printing out these trues and falses. Let me put a little print here. Okay, we can do the less than. So print a less than b. It doesn't matter if I have spaces or not here. I can just execute it like that if I want, and I get true. I tend to have spaces just for readability, but it's up to you how you want to write your code. And then I could do print, let's see, is a greater than or equal to b? And I get false. And I remind you that a is 10, b is 20. So if I do greater than or equal to, a is not greater than or equal to. But if I do print a less than or equal to b, let me put a print statement here. If I do a less than or equal to b, that is true. And I don't have to just compare variables. I could do print a less than or, why do I keep hitting the wrong one? Less than or equal to 10. I'll get true because it is equal to 10. I could do 11 and I'll get false because a is not equal to that. If I want to check and see if 2 things are equal, again, I use the equals equals. So print a equals 10. Let me put a little blank up here. And I get, oh, they are equal to one another. Let me copy these up here so that we can still see them in the screen as I'm doing these equals. Print word 1 equal word 2. And I see that I can test these strings. I could print word 1 equals word 3. These are not equal to one another, and I get a false. And you might be asking yourself, well, can I compare to see if they're greater than or equal to each other? Is this greater than or equal to, or greater than equal to word 3? And I get a true here, but of course that doesn't really mean anything. It doesn't check the length or anything. It doesn't mean anything right off the bat. These letters do have values associated with them, but they don't have anything to do with like the length of the word. So generally, unless you really know what you're doing, you do not want to be comparing like greater than or equal to with these strings. And you can check to see if two things are not equal to each other. So you can do print, let me put a blank line up here. So let's remember b is equal to 10, but if I do is b not equal to 20, that's actually, oh, b is equal to 20. Haha. So I get false, not equal to 20, because it is equal to 20. If I do b not equal to 10, it's true. And just to remind you here, I'll put a little print statement here. Print fb, and then I'll put the value of b in there. So b is 20, that means it's not equal to 10. And you can do, if I do print word 1 not equal to word 2, I should get false because those are actually the same word. They're the same value. Okay. Now up here, I've just been printing what was returned by these comparisons, but I can actually set a variable to be equal to a Boolean quantity. So I could do test equals, let's do this again, a equals 10, b equals 20. So test, and then you could do b greater than a. So I'm going to set the value of test to be equal to whatever is returned by b is equal to a. And if I print f string test, I see that the value of the value of test is now true. And I can actually use this if I want to in an if statement, which is what we'll find soon. And if I wanted to even, I could just do x is equal to true if I wanted. Why can't I spell today? X is equal to 2, and if I print x true, I can see that the value is set to be true. So let's try some simple if statements. I'm going to remind you that everything that is indented is executed. Looks like I can't spell here. You can fix this if you want. Everything that's indented is executed if the statement is true. Now let me just say I sympathize with you when you start getting in more complicated stuff. Tracking down all these different steps in the logic can be time consuming. So you want to think about this very clearly. Think about what the program is doing as it goes into each of these if statements. So let's try something here. So we'll do a simple if statement. We'll say that a is equal to 10, let's say. And if a is greater than 5, we can have a print statement. A is greater than 5. And if I run this code, it goes into this and it says a is greater than 5. If a was equal to 1, what do you think would happen? Well, if a is greater than 5, it's going to print this out. But if a is not greater than 5, nothing happens at all. It never executes this cell. So let me put this back to 10 here. A is greater than 5. And everything that's indented is run if this statement is passed, if this is true. So if I wanted to, I could then have here some f string, printing the value of a. So again, this only happens if this statement is true. Works for 6. Does not work for 4. I'll just leave it at 10 for now. And we can also have an else statement, and this only happens if the first statement is false. So let's go back. Let's do A equals 10 so we can keep everything in one cell just for while we're playing around with this. If A is greater than 5, we're going to print A is greater than 5. And then we're going to have an else statement, and I want you to be very careful about how it's indented, because it has to be at the same level of indentation as our if statement. And now we can print here A is less than or equal to 5. So we get our A is greater than 5, but if this was equal to 5, we go to this would evaluate as false. So it would say, is A greater than 5? No. Go to the next option. We find there's only one option here. And so it would print A is less than or equal to 5. And of course, we can have other print statements in each of these if we want. Hooray. A is less than, print. Boo. I don't know. I'm just pointing out that you can have more stuff in here inside these indent statements. We can also have and or operators, and in Python, these are just the English word and the English word or. So let's do A is equal to 20, let's say. If A is greater than 10 and A is less than 30, we can do print A is between 10 and 30. And then we can have an else if we wanted. Otherwise, print A is not between 10 and 30. So look at this here. A is greater than 10 and A is greater than 30. So this only works if both of these are true. This is true and this is true. A is between 10 and 30. If this was, let's say, 2, A is not between 10 and 30 because both of these need to be true. And you can have more complicated expressions in your and statements if you wanted. We can also have or statements. So if A, let's pick a good one here. So if A is, let's say, less than 10 or A is greater than 30, we can do print A is less than 10 or A is greater than 30. I'm not even going to have an else statement for that. I'm just going to have that down here. And notice that when this is 20, this does not evaluate, right? Because 20 is not less than 10 or greater than 30. But if this was 2, then it would be less than 10 or greater than 30. So with an or statement, at least one of these has to be true. And I say at least because you could have many, many or statements. So A is 2. This one turns into true. This one is false, but it can be true or false. If one of these is true, then it prints that last line. Okay. And then we can have multiple options with this. I mentioned an elif statement. This is just smushing together else and if. You always have to have something after that. And you can think of this, it's a kind of like convoluted English language statement, but you could do if this, do that, else or else, do this other thing, then do something else. Now, your branching will only go to these elif statements if the first elif or the first if or any elif statements before it all fail if they're false. If any of them are true, it never goes past those. So let's see what we mean by that. So let's do some elif statements here. Let's suppose that x is equal to 100. We'll do some tests with that. So if x is greater than, let's say, 1,000, we will print, x is a really big number. something like that. And then we could have elif, and now we can't just have else after this. We have to have some other option. So if x is greater than 100 and x is less than 200, then we could print that x is between 100 and 200. We could have another elif here saying that if else x is less than 5 or x is greater than, let's say, 20, print x is less than 5 or x is greater than 20. And if we're just tired of all these things, we could just say else at the end. We could just print, x is a number. And so let's try some different numbers and see what happens with this. So I run this again. We get x equals 100, and we get x is less than 5 or x is greater than 20. So let's see how we got here. So it says if x is greater than 1,000, x is a really big number. It's not greater than 1,000, so it fails here, so it goes to the next one. If x is greater than 100 and less than 200, x is between 100 and 200. However, x is actually 100, so it's not greater than 100. This and statement means both of these need to be true, and so this whole statement fails. Another option then we go to is if x is less than 5 or x is greater than 20, then x is less than 5 or x is greater than 20, and that's what we print out. So what happens if we do x is equal to 101? Well, you might expect that it gets to the same point. X is less than 5 or x is greater than 20. It is greater than 20, but when we run it, we get that x is between 100 and 200. And that's because Python's going in order. It says, well, is x greater than 1,000? No. So let's go to the next step. X is greater than 100. Yep. And x is greater than 200. Yep. So as soon as it gets to this point, it prints this out and then stops the whole checking statement. As soon as it gets to something, it branches out of all of these options and then does not execute anything after that. So it keeps marching through until it gets to a true statement and then stops. And then we can just check out these other ones. 1,091, that's greater than 1,000. It's a really big number. I don't know if we can get any other options in here. If I put 6, then I get that x is a number because it is not greater than 1,000. It is not between 100 and 200. It is not less than 5 or greater than 20. And so we get to the very end, x is a number. And so that's a few different branchings that we had to worry about. So let's try a few other things with input functions. This is where Python in the notebook can actually ask the user to enter in some data, and then our program is going to process it. So this is almost like one of those choose your own adventure stories. So the user is going to type in some input, and then we're going to have some conditional statements to print out some things based on the number of characters that were typed in. So if the user typed in more than 16 characters, we're going to print out, wow, you type a lot. If the user typed in less than or equal to 3 characters, we'll print out, not much of a talker, are you? If the user typed in more than 3 characters but less than 7, we'll print out short and to the point. If the user typed in exactly 7 characters, we'll print out lucky 7. And if the user typed any other number of characters, we'll type nice job. And even though all of these have just one if at the beginning, we're going to use if and elif and else for our code. So the first thing we're going to use is this input function, which is built into Python. So I'm going to have response is equal to input. And then just to show you what happens, I can do print response. And if I execute this cell, I get this little text entry box, and I can do hi there. And now if I hit enter, it prints hi there. We also get the actual initial thing that we typed in. It just shows us what we've got, but I'm printing it again. Okay, I'm not going to print that right now. we're just going to go into our if statements. I'm going to try to give us some room. So the first thing I'll do is I'll get the number of characters. I'll call it n chars for number of characters, but you can call it whatever you want. You can call it n if you want, or capital N, number if you want. And that's going to equal the length of the response. Just to remind you, len returns the length of a string or list. It returns the number of characters in there. So if the user typed in more than 16 characters, so if n chars is greater than 16, oops, I forgot my colon. We're going to print, wow, you type a lot. Elif, here's another thing. If the user, if n chars is less than or equal to 3, colon, print, not much of a talker, are you? We'll have another option here, which we'll use an elif for. Elif n chars is greater than 3, but less than 7. So that means that both of those things have to be true. So greater than 3 and n chars is less than 7. Less than 7. Then we will print out short and to the point. If the user typed exactly 7 characters, we'll print out lucky 7. Elif n chars is equal to 7. Then we'll print lucky 7. Otherwise, if nothing happens, then we will print nice job. I have a lot of exclamation points because I'm very excited to be typing Python today. All right, so we run this and we're going to enter in some values. Let's try to get more than 16 characters. So we can type, hello, how are you? What a nice day. I don't exactly know how many characters that is, but that's a lot. And so if I hit enter, wow, you type a lot. So greater than 16. I can go back and I can run this cell again. I get my input again. Let's do between 3 and 7. So hello, that's 5 characters. It's not greater than 16. It's not less than or equal to 3. So we should get between 3 and 7, short and to the point. Let's try this again, see if the other ones work. If I just type hi, that's less than or equal to 3. Not much of a talker, are you? If we run it again, let's see if we can get 7 characters. So hello, that's 5. Hello, me. I don't know. It's 7 characters, it'll work. That's the lucky 7. And then if we type anything else, so I think 8 will get to the end. Hello, me, because there's a space in there, that should be 8 characters. I get the nice job. Cool. So make sure you fully understand how all this works, the syntax, the fact that these are all lined up, which is not going to be exactly this. They're not all going to be lined up in the next section where we're going to talk about nested conditionals. So if you remember when we talked about loops, we had nested loops, which are loops within loops. And similarly, we can have nested conditionals where you might have some sub-decision to be made. And this is really like a choose your own adventure. If one choice is made, it leads to another choice or even a set of choices. So we'll use the input function again, and we're going to prompt the user to pick a number between 1 and 1,000,000. Because this function is going to expect a string, it's going to return it as a string, we're going to have to turn this into an integer. Now, if the number is greater than 1,000,000, we'll print out that the number is too big. But if the number is between 1 and 1,000,000, then we're going to check to see if it's even. If it's even, we'll let the user know. If it's odd, we'll let the user know. And if it's anything else like 0 or a negative number, we'll let the user know it's not between 1 and 1,000,000. So let's do this. Response equals, and then we'll have the input. And now in here, we could do enter in a number between 1 and 1,000,000. We'll print response, And then I'm going to print the type of that response is. So what is that data type? So now we get our prompt here, and I'm going to put a colon here and a space at the end. This will make it a little bit easier. So let's suppose I enter 10 and I hit enter. I get 10, but it's a string. So what we want to do here is we want to say that response is equal to int response. And if we want to use a different variable, let's call this num for the number. So our number is an integer of response. We'll print what num is. It's going to look the same, but when I look at the type of number, I've turned it into a integer, or I've cast it as an integer. The terminology in computer science is that I've cast it. Okay, so let's do our checks. If num is greater than 1, 1, 2, 3, 1, 2, 3, that's 1,000,000, so 6 zeros. Then we will print this number is too big. And then I'll do another print statement, enter a smaller number. Okay, I won't use an exclamation point because I don't want to yell at the person too much. Okay, elif num is greater than or equal to 1, and num is less than or equal to 1, 1, 2, 3, 4, 5, 6, 1,000,000. So now it's between there. Now notice my indent here. I'm going to do another if statement. If num, we're going to check to see if it's even. And how do we do that? Well, we want to check to see if I divide it by 2. If it's even, the remainder should be 0. So I'm going to use the little parentheses here. I'll put a space so it's easier to see. If I get the remainder after dividing by 2, that should be equal to 0. Print, and I'll do a f string here. Num is even. And even though there's only one other thing it could do, but I will do this as an elif statement, even though I could just do an else if I wanted to. If the remainder is equal to 1 when I divide by 2, then it must be odd. Okay, so that only goes into these. It only goes in here if it passes this statement. So if it fails this, it goes to this elif, and now because these are indented down below, it is only in this region here. But I can come back out and de-indent to this else here. And now it's checking if it's anything else like 0 or a negative number, then we print, I'll use an f statement, f string, sorry. Num is not between 1 and 1,000,000. Okay, so let's try this out. Enter in a number between not 1 and 1,000,000. I'm going to enter in just a much, much bigger number just to see what happens. This number is too big. Enter a smaller number. Fine. I'll run it again. Enter a number between 1 and 1,000,000. I'll enter 10. 10 is even. So it got into this section here. Then it got to these if statements. So these are your nested if statements, and you could even have nested statements even inside there. It checks to see if this the remainder when I divide by 2 is equal to 0, and if it is even. But if the remainder is not that, if it's 1, then 11 is odd. And then if I run this and I enter in 0, then I get 0 is not between 1 and 1,000,000. Now, I typed this all kind of close to one another so you could see what was happening. I wanted to make sure that everything kind of stayed on the screen. I tend to have spaces just to make things a little bit more readable, and so on. Okay. Other functions return values that you can test on. So in all strings, there's a find function. and it lets you search for a given word or string inside the primary string. And what it does is it returns the first index where it finds that number. I'll ask you to edit this. This should not be number, where it finds that character or string. Okay, there we go. So it finds the first index where it finds that character or string. So if the first character or substring is at the beginning, it returns 0, -1 if it doesn't find it. Okay, so let's try this out here. So words, we're going to use the name of an album by Godspeed You Black Emperor. Lift your skinny fists like antennas to heaven. So that's our words. And what we can do is this. We can do x equals words.find, and we'll look for L. And print x. And if we look for L, it returns 0, and that's because it found L at the very beginning. If we searched for I, it'll return the first index it finds, I, and that's 1. So remember, we started 0, 0, 1. Now, if you wanted to look for other values of I, you can tell this to search at a later spot. So you could tell it to start searching at index 2, and it would start at 2. So now it skips over the first I to 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and that's right, return 12. But usually we're just looking for the first instance that something occurs. So if I look for fists, I get 17. So it'll look for a whole string here, and it'll look for it. Now, if I searched in here for, let's say, Matt, it's not going to find Matt in here. And so what it does is it returns -1. So if it returns 0 or anything higher, then it found that character, that letter, or it found the word in this. And so we could use this in a conditional statement. Pardon me. So we'll use the input function, prompt the user to enter the month of their birthday. If they enter in April, or April with a capital A, we'll print out April showers bring May flowers. If they enter in October with a lower or uppercase, we'll print out I'm getting you pumpkins for your birthday. Otherwise, print out hope you have a good birthday. So we'll do response equals input. And then we will say when, or we'll say, how about this? What month is your birthday? We'll have a question mark. We'll have a space after that. Then we'll do if response dot find, and now we'll search for April, lowercase, or, and we've got to do the whole search again, response dot find April. Let's just test this out. Then we will say print April showers bring May flowers. And so this looks like it would work. If it finds April or capital April, then this should work. So we'll try this out. What month is your birthday? I will try April. And I get April showers bring May flowers. Okay, so it's saying April showers bring May flowers. Okay. Okay, so let's try this out. So we try April, and we enter it, and it says, oh, April showers bring May flowers. Oops, I've got an extra parentheses here. Now what happens if we type May? Wait a minute. That doesn't make sense. April showers bring May flowers. This must be interpreting these with the 0 or -1 as it finds everything, the -1 as a true statement. Somehow it's saying that -1 is true. So let's do this. We've got to be very explicit about what we're doing. If it finds this and the value that it returns is greater than or equal to 0, that means it found it. So we can't just say, oh, if it found it, we've got to make sure that it is greater than or equal to 0. Otherwise, we're going to get false values because 0 means it found it at the beginning. Anything higher means it found it later in it. So now let's try this. What month is your birthday? We'll check and make sure April works. Awesome. What if we do May? Nothing happens. Phew. Okay, this is making sense. What if someone types something more complicated, though? What month is your birthday? My birthday is in April. Is it going to find it? Yes, because April, even though it was later in it, 0, 1, 2, 3, blah, 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 it was later in it. All we require is that it finds it at greater than or equal to 0, greater than or equal to the first spot. And then we can do an elif. Elif response dot find, and now we know that we're going to look for October in greater than or equal to 0 spot, or response dot find October greater than or equal to 0, and then we'll print I'm getting you pumpkins for your birthday. Okay, let's see. Oh, and then we've got an else in there. Else, we'll just say print happy birthday. Okay, let's see if this works. What month is your birthday? Let's make sure we didn't break anything. April. I'll even have an exclamation point at the end. Is it going to find April? Yes. April showers bring May flowers. We'll run this again. What month is your birthday? May. Happy birthday. And if we put October, I'm getting you pumpkins. Yay. So now here's where, if I've only got these two options, if I just say oct, it doesn't actually get to that because I'm looking for the whole string. Now you could change to look for just OCT if you wanted to, and that's an option if you were coding this up for a real, some sort of choose your own adventure or text-based game. The last thing I want to show you actually goes back to the loops and how we can use if statements to break out of a loop earlier. There is a break statement, a Python function, that will exit a loop. It will break the loop. So let's look at an example. Suppose we have a for loop, and that for loop is adding up the multiples of 5 from 5 to 100. But we're going to break out of the loop early if it turns out that the total is 200 or greater. So total equals 0. For I in range, and we'll start at 5, we'll go up to 101, let's say, just so we get to 100, and we'll go in steps of 5. And then here I'll have total plus equals I. We're going to keep adding to it. And then at the end, we'll print the total. I don't know what this actually comes out to, 1,050. And if we want to, we can have a little print statement in here. We'll probably get a lot of stuff. Let's do it with an F string. And we'll have I to show what the value is. And then we'll have the total. And so first we add 5, then we add 10, then we add 15, and so on and so on. And what we want to do is we want to break out of this if the total is greater than or equal to 100. So if inside the loop, notice I'm inside the loop here, if total is greater than or equal to 200, then I break. And this break says like, hey, if this statement is inside a loop, then break that loop early. So instead of going all the way to the end to 100, it'll break once the total gets greater than 200 or greater than 200, which it does when it's at 225. So out here, I could have a little F string that says outside the loop, total is, and I've got that in the little curly brackets. So once it's finished, the total is 225. So I've added a little bit more control flow to this loop. We'll be using conditionals a lot the rest of the term. So don't worry, you'll be getting plenty of practice. As always, if you have questions, please reach out to me, Learning Assistant, or your peers, and we're all happy to help you. Okay, bye for now. Take care.